Today we'll be talking about using machine learning in our 326 project. The basis of our project is a movie recommendation system in which the user provides the title of a movie. They're presented with a list of recommended movies that include the background descriptions and information about the movie, actors, directors, and other metadata about the movie. So here we have data set that's input, and then we clean that data set with the information that we need with title and soup columns. And the soup column is called this because it takes a combination of multiple forms of data, including keywords about the movie title, cast names within the movie title, the director's name, as well as the genres it falls under. So as you can see for Avatar, we have culture class, future, and space war are key words that would identify the movie title. We have cast names. We have the director, who's James Cameron, and then we have the genres of action, adventure, and fantasy. And for every single movie within this data set, it's been reduced to this data.
For our machine learning, we use the count vectorized object, which implements tokenization and the occurrence counting in the sum class. We used the fit transform, which learns the vocabulary and it returns a term matrix. The soup column values are then vectorized, and as you can see below, we have an example of that. And we use our count matrix shape to show 4,803 rows and an example of 11,528 unique words. Next, we're going to use our cosine similarity function from the sklearn metrics pairwise. So on the count matrix, we define the cosine similarity, and then we have some math functions with cosine similarity and two matrices. This normalizes the x and y arrays, transposes y, and calculates a value 0 to 1 for each xy array, and it returns a matrix of values. In our case, for returning a 4,800 by 4,800 matrix of similarity values, and the highest similarity between the two compared text rows of the vectors means that there is a higher similarity cosine value.
So as you can see here, we create a series from a movie data set with indices and titles. So we select from the index our movie title, which is in this case Iron Man 3, which is has the index 31. And then we extract the row for this movie title from the cosine scores, and then we sort it. So then we can recommend movies with these indices with the higher cosine similarity values, which is the first 5 of them, and then we can skip the first one as its own similarity value, which is equal to around 1. And so this is kind of like a rundown of our program and how a little example of the matrix formation. And so these are the sorted sim scores for the IMN 3, which is index 31. So it sorts all of the movies that are similar to Iron Man 3. And as you can see, after 31, which is Iron Man 3, and everything after that are the movies that are the most similar to that movie itself. So as you can see, the index, and then it has the cosine similarity value next to it. So there's a total of 4,800 similarity scores, but we only want the first 5 of them. So, and then again, here we are. This is a more of a better rundown of it. As you can see, there's Iron Man 3. It has Terrorists, War on Terror, Tennessee, Robert Downey Jr., all the cast and the directors. And then it takes the top 10 similarity values from other movies, and then it recommends the movies that would be the most similar to Iron Man 3. So obviously it would be Iron Man 2, and then all the Avengers movies, and then Captain America. And then so to the right, the table here is the index value of that movie within the data set. And then on the bottom with the similarity value it gives a value related to how close it is to the movie that is inputted by the user.
All right, so this is our code that we're going to go through and talk about some of the problems that we faced. One of the first problems that I'm going to touch on was the trouble of understanding the machine learning and the cosine similarity. We had to debug and print a lot of variables to understand what was happening. Another issue we had was the GUI screens. They were a little tricky to place the widgets. And it was difficult to use the big and complex data sets with the complex data structures. Another issue was that getting a user input and formatting the output took some time. And the final issue was that even though there's a lot of online help, dealing with the Python libraries and packages can get complex because there is a lot of them.
So now I'm going to run through a little bit of how our program works. So if you're in VS Code, you're going to want to open up a terminal, and then you're going to type in the movie recommendation GUI, and then press enter. It might take a second to boot up, but after it's done, it's going to open up a screen on your computer, and you're going to be able to type in any movie that you want to. This has about 5,000 movies in it, so you should be able to type in anything basically. Once this screen pops up, here we go. Here's the GUI, and then let's say you want to look up a movie like Avatar. It's going to give you a bunch of recommendations, so it just autofills for you, and then you're going to click on that, press search, and then it might take another second. And then here you go. You have all of your recommendations for the movie Avatar, the closest recommendations. It has the title, the genre, the cast, and then the homepage if it's available. If it's not available, it's going to give a little message that says homepage not available right here. And if you need any help, there's a help button also. And then, yeah, so it starts off with the closest movie to Avatar, and then the further it goes, the less of the cosine similarity it is. So movies like The Monkey King won't be as similar to like Pirates of the Caribbean, but these are the top movies that are closest to Avatar, and it's a little rundown of how our program functions.